In 2025, three major scientific discoveries are overturning humanity's understanding of reality, especially the last one, which may rewrite Earth's fate. Astronomers have observed that the expansion of the universe is slowing down. Strange matter hidden deep within Earth for billions of years has been discovered, and the very first black holes began wandering the cosmos before galaxies even formed. Any one of these three discoveries would be enough to tear apart our textbooks. Yet all of them have been confirmed this year. Scientists are collectively losing sleep. What kind of world are we actually living in? Today, I'll walk you through these three mind-bending discoveries, each of which could rewrite how we understand reality. Let's start with the Webb Space Telescope's stunning discovery. Recently, Webb captured a group of tiny red dots deep in the universe for the first time. QS01 is one of them. At first, scientists were completely baffled. What exactly was this thing? And why could we see it from so incredibly far away? To figure it out, research teams spent day after day observing these red dots. Analyzing their spectra in detail, they discovered that each of these red dots had a distinctive V-shaped curve in its spectrum. This indicated that gas was orbiting something at extremely high speeds. Then in September 2025, the answer was finally revealed. QS01 turned out to be a supermassive black hole weighing 50 million times the mass of the Sun, more than 10 times larger than Sagittarius A*, the black hole at the center of the Milky Way. But the most shocking part wasn't its size. It was the fact that it was wandering through the universe. This kind of object is known as a rogue black hole. We know that nearly every galaxy has a supermassive black hole at its center. And those black holes are usually quite modest. Their mass is only about 1,000th of their host galaxy. But QS01 is different. Its mass accounts for 2/3 of all the surrounding matter. And there isn't even a hint of a galaxy nearby. Even more astonishing, when scientists analyzed the gas around it, they found only hydrogen and helium, the only two elements that existed just after the Big Bang. What does that mean? It means QS01 became a supermassive black hole before the first generation of stars ever formed. We used to believe that galaxies formed first, and black holes came later. QS01 flips that logic completely upside down. So what's going on here? Scientists have proposed two possible explanations. Either enormous gas clouds in the early universe collapsed directly into black holes, or, as Stephen Hawking suggested back in 1971, these black holes formed during the Big Bang itself, earlier than stars and galaxies, wandering the universe until gas drifted close enough for us to detect them. In other words, those tiny red dots Webb captured may all be supermassive black holes. To uncover the truth, Webb will continue tracking these red dots in the future. If the black hole discovery overturns our assumptions, then the new findings about dark energy may rewrite cosmology textbooks entirely. In April 2024, nearly 1,000 astrophysicists used the DESI Dark Energy Spectroscopic Instrument to analyze the positions and motions of over 6 million galaxies, and reached a shocking conclusion. The dark energy driving cosmic expansion may be weakening. At first, no one dared to believe it. After all, for the past 27 years we've assumed dark energy was constant. And that assumption underpins the standard model of cosmology. But in 2025, the DESI team released even larger datasets, covering 15 million galaxies. Combined with supernova observations and cosmic microwave background data, not only did the signal persist, it became even stronger. Here's a quick explanation. DESI measures cosmic expansion by detecting baryon acoustic oscillations, sound waves left over from the early universe. As the universe expands, the spacing between these ripples increases. DESI found that this expansion rate isn't constant. It's slowing down. Statistically, the 2024 result had about a 1 in 30,000 chance of being a fluke. By 2025, it had risen close to the widely accepted gold standard threshold. And multiple independent datasets all point in the same direction, which makes it impossible to ignore. If dark energy really is evolving, then we're faced with a huge question. Why is it changing, and what exactly is it? Some scientists even speculate that this may not be a dark energy problem at all, but that Einstein's general relativity needs revision on cosmic scales. To resolve this, scientists are placing their hopes on the Vera Rubin Observatory, which will detect hundreds of thousands of supernovae, providing datasets orders of magnitude larger than what we have now. By then, we'll know for sure whether dark energy is truly slowing down. This is a golden age for cosmology. Humanity may be standing on the brink of a cognitive revolution, as profound as the one in Einstein's era. After the universe, let's look beneath our feet. Scientists used to believe there was a clear boundary between Earth's mantle and core, each doing its own thing. But two studies in 2025 shattered that idea completely. The core and mantle have been interacting all along, and the bridge between them is two enormous mysterious structures. These structures sit at the base of the mantle, beneath Africa and the Pacific Plate, each roughly the size of a continent. When scientists used seismic waves to perform CT scans of Earth, they found that waves passing through these regions slowed dramatically, earning them the nickname superplumes. A team from Utrecht University in the Netherlands analyzed data from 100 major earthquakes. They originally assumed these hot regions would weaken seismic waves, but instead found that the waves emerged with almost no loss of energy. What does that tell us? It means the crystals inside these structures are extremely large, and the larger the crystals, the more easily seismic waves pass through. Large crystals also mean extreme age. These structures may be reservoirs of material left behind when Earth first formed, or even from the Theia impact that created the Moon. The most decisive evidence comes from isotope studies. Researchers focused on a rare metal called ruthenium, which has a strong affinity for iron. During Earth's formation, ruthenium-100 should have sunk into the core with iron, leaving very little in the mantle. Yet scientists found ruthenium-100 in volcanic rocks, and traced its origin directly to the core. It most likely rose from those two massive hot rock structures at the base of the mantle. Taken together, the picture becomes clear. These superplumes are the bridge between Earth's core and mantle, acting like gigantic anchor points, shaping mantle convection. And mantle convection is the driving force behind plate tectonics. This also explains why Earth is so geologically active and capable of supporting life. While Mars, lacking internal activity, became a dead planet long ago, we now know that Earth's interior is not lifeless, but a dynamic system that has been active for billions of years. Understanding this process helps explain why Earth became a habitable world. To sum up these three major discoveries of 2025, rogue black holes existed in the early universe. Dark energy may be slowing down, and Earth's core and mantle are secretly interacting. Each one shatters our long-held assumptions. That's the beauty of science. There are always new secrets waiting for us to uncover. After watching this, which discovery fascinated you the most? And who do you think came first, black holes or galaxies? Share your thoughts in the comments.